In this video, we will discuss the solution of question number 112. So this question was asked for 1 mark. Under which combination of conditions does the glass transition temperature, that is Tg, of a polymer increase? And options are increase in molecular weight and increase in plasticizer content, B, increase in plasticizer content and decrease in cross-linking, C, increase in branching and decrease in interchain interaction, D, increase in chain length and decrease in plasticizer content. Before going into the solution, we should know what is glass transition temperature. So this temperature, glass transition temperature, is the temperature at which polymer changes from hard and glassy state to soft and rubbery state. Okay, this is the transition from glassy or hard state to the soft or rubbery. Okay, so it depends on what? Chain mobility. Anything that restrict the motion of chain which increase the glass transition temperature. Okay, and anything that enhances the mobility decreases the glass transition temperature. So this is the fundamental. So let's see each factor given in the question. Molecular weight or chain length. Okay, so Tg goes up to a certain limit. Explanation: longer chain have more entangle and less mobility. If chain is longer, okay, so there are chances to entanglement, get it entangled more. If it's short, it will not entangle more. Okay, so that is the fundamental. Plasticizer content, which decreases the Tg. Okay, this plasticizer decreases the Tg. Why? Because it increases the free volume. Okay, this plasticizer gets in between the polymer chain. Okay, it sits here, then the free volume gets increases. Okay, so because of that free volume, chain mobility gets increased, which helps to reduce the glass transition temperature. Cross linking, that which increases the glass transition temperature. Okay, this cross link restrict the motion of polymer chain. Okay, also it decreases the free volume in the polymer network. So that's why the glass transition temperature is increased by cross linking. Branching usually helps to lower the glass transition temperature. Why? Because this branching, what it did, it prevents close packing of the polymer chain. Hence, the interchain attraction gets reduced, and which helps to reduce the glass transition temperature. Interchain interaction, okay, which helps to increase the glass transition temperature. Strong secondary forces restricted the mobility. Okay, if there are too much hydrogen bonding, okay, so it will have some secondary sort of interaction. Okay, so which restrict the mobility. Hence the glass transition temperature in the interchain interaction, okay, like secondary interaction, hydrogen bonding or polarity, it get increased. Tg, it enhance the Tg. So among the option, if we increase the molecular weight and increase the plasticizer content, here plasticizer will dominate and Tg will get decreased. Option B is with increasing plasticizer and decreasing cross-linking, both reduces the restriction. Okay, hence the chain mobility will be too less. Okay, so because of that, free volume will also be less, so it decreases the glass transition temperature. C, with increasing branching and decrease in interchain interaction. Okay, so this both it enhance the mobility of the polymer chain. Okay, so it also helps to decrease glass transition temperature. Okay, D is with increasing chain length and decrease in plasticizer content. Here they both restrict the motion of polymer chain. Okay, so here free volume will be very less, which will help to enhance the glass transition temperature. In this case, glass transition temperature will be more. The glass transition temperature is depends on how easily polymer chains can move. Okay, how easily a polymer chains are like that, how easily it can move. Okay, so it depends on that. When chains are longer, high molecular weight, they are more entangled. Okay, and they can't move easily. So in that case, what, TG goes up. Plasticizer on the other hand, it acts as a lubricant. They increase free volume in the polymer network. Therefore, the combination that increases glass transition temperature is longer chain with less plasticizer. So here this option D is the correct option.